Hello everybody. Today we're going to be applying similarity, and you're going to see a lot of things you've seen from last year with triangles congruency, like side angle side theorems, but it's going to apply to similarity this time around, which means we're going to be working with scale factor. Go ahead and copy down the I can statements, and then when the vocabulary comes up, you're also going to want to copy what's there word for word, as well as have the pictures. Okay, so here are our similarity statements, or theorems, you might hear us call that. We have angle angle, which is AA. We have side angle side, which is SAS. We had side side side, similarity also. Those should sound familiar from last year, other than the AA. Yes, we noticed we can't spell proportional. It's PROPOR. So you may want to take a minute and copy all these down with the pictures before or after you listen to us talk through them. Angle angle simply says as long as you can prove two angles of one triangle are congruent to, which means completely match, exactly equal to the two angles of another triangle, then the two triangles are definitely similar. Side angle side and side 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 has to do with matching up two sides or three sides, but they do not have to be congruent. They only have to be proportional, which means they're going to be in the same scale factor. As long as that's true, you're good. And then side angle side, as you read that, notice it's two matching sides and the angle included in between those sides. And side side side, of course, is all three. And every year we have to say this. Of course, there's a SAS and SSS. There is no ASS for a reason. The other thing of importance here is to please notice, if you're not real familiar with it, how someone names triangles or how you name the triangles. If you say triangle ABC is similar to triangle DEF, then you're saying A matches with D, B with E, C with F, and likewise AB with side DE, side AC with side DF, and so on. So lots of times just looking at that statement right there and the way you can read it is even better and quicker than looking at the picture. Okay, let's start example 1, and they've got two things going on. They want us to make sure we can understand and explain and prove why the two triangles are similar to each other in that order, and then to find the length of DF. So we're going to assume that they are definitely similar, but we've got to prove that. So the first thing to do is write down or look at how they have them written down. I like to do things like underline, matching sides. It helps me out. If I can write this small, AB matches with DE. AC, for instance, matches with DF, and you can do any other types of markings you want to do. So let's write out so that we can prove the similarity. We're looking for, can we prove either the angle-angle similarity theorem, the side angle side, or the side side side. So let's take anything we've got from the picture and let's write it down. First thing we see is angle A and D marked the same. So angle A is marked congruent to angle D. Please try to get good with your notation and be careful about how you write things. So that is a set of angles. Do we have any other angles marked? And if we do, we could be done with just angle angle. I think we do. We have angle C with the two little curves matching angle F's marks. So angle C is congruent to angle F. So there's another angle. And that alone means we could stop. We could check some sides, but there's nothing else to worry about because we can say, yes, they're similar by the angle-angle theorem or statement. Now, because they're similar, we can find the length of DF. So what you want to do is you want to match up DF and its matching side into a proportion with any other set of matching sides that you happen to have information for. DF, a good way to find that would be the way we marked it right here in red. DF matches with AC. Whether you look on the picture or not, you know that has to be true. So DF matches with AC. And let's set up any other set of sides that happen to have numbers on them because we're looking for DF, so we could call that X. We have AC, that's 6.9. The other matching sides would be the 2.72 and the 3.4. You have to mark them, you have to write them in the same order you set up the DF to AC. That's all that matters. So DF came from this triangle, so we've got to put aside from that triangle on top. So let's put DE matches with AB. Let's fill in numbers and use the X for our missing part, and you'll see how easy the math is. DF we don't know, AC is 6.9, DE is 2.72, AB is 3.4. Do your cross products. Use your calculator. Make sure I don't screw up and make mistakes. What I have is 18.768 equals 3.4x. Divide both sides by 3.4. I came out with 5.52 for the value of x. So the length of DF is what was missing. That's what we called x. So DF is 5.52 units. The math is super easy. You should love that part. Example 2, the best part about the geometry unit is drawing the pictures, except unless you're me and you draw really badly. So we've got this person standing here in the sun, and they make a shadow on the ground. So that's kind of their head, and there's the shadow. The sun is shining from up here. At the same time of the day, you've got a flagpole, probably a lot taller than my person, but I didn't leave myself room to draw it. Also making a shadow on the ground. I know you're jealous of my drawing abilities. The sun's hitting that, even though I don't have them drawn side by side, the sun is hitting the flagpole at the exact same angle. So what we have here is we can make a triangle from the sun shining, and as long as they're similar triangles, we can use similarity to figure out missing sides. So the person is 5 foot 10 inches tall. The shadow is 3 feet 6 inches long. At the same time, the flagpole, which we don't know how tall it is, and yep, that's what they ask, is casting a shadow that's 12 feet long. So I hope you're already thinking we've got to be in similar units, so probably the best thing to do would be change this to inches so you don't have to use decimals for your feet, and then we can go back to feet since the question is to the nearest foot, how tall is the flagpole? So first let's make sure we have similar triangles, and I'm just going to go ahead and tell you we do. It's by angle once again, and let me show you those because later on in the next week or so you're going to have to make sure you know this. There's one set of angles that are the same because we're going to assume if we're standing up in the sun and if a flagpole is standing there on the ground, they're both at right angles with the ground. The other angle that we have that is the same would be the sun shining down making the shadow. So whatever object is in the sunshine would be making an angle on the ground for the shadow at the same time of day at the exact same angle as anything else. So those would be similar angles, therefore, those would be congruent angles, so therefore we'd have angle similarity. Now all we need to do is set up a proportion to solve it. You just need to set it up with matching units, and I'm going to go ahead and change to inches also. Okay, I've already written out my appropriate inches for the 5 foot 10 inches and 3 foot 6 inches and 12 feet. And now I'm going to set up matching sides. You may not see the exact same one I see first. We'll write at least 2 or 3, but the cool thing is, as long as you use a matching proportion, you and someone else can use different ones and still get the same answer. I'm going to do the person's height to the flagpole's height should go in the same order as the person's shadow to the flagpole's shadow. That would work for me. Or if your eyes didn't see that, you might want to do person to their shadow, 70 to 42 would be matched to the flagpole to its shadow. Or maybe you see it a different way. You may see, maybe you always want to start with a missing value. So I see X, and then I'm going to match it up to the 70 because the flagpole and the person are both the straight up and down sides of the triangle. Then I would have to go, if I go X to 70, I have to stick to this triangle over here back to that one. So I'd have to go 144 to 42. Any of these will work because if you'll look closely, they all have the same cross products going on. 70 times 144, the 42 times x. In each situation, that's why the math gives you the same answer. When you do the cross products, you should get a 42x equals 10,080. Do your division. X should be 240 inches. That is our answer for how tall the flagpole is. The question is how tall to the nearest foot. So if I simply take 240 inches and divide it by 12 inches per foot, it should come out to be right at 20 feet. The flagpole is 20 feet tall. Just in time for Valentine's Day. Okay, example 3. They want us to determine whether the triangles are similar. So we are after looking for angle, angle, side, or side, side in order to prove that. The first thing I would spot is that we definitely have an angle because we have angle A is congruent to angle E. So we have one angle. There are no other angles listed or marked the same here, so angle is probably out. Side is probably out because we only have 2 numbers on each triangle for side lengths. Plus we already have an angle, so we're trying to find out by side, angle, side to prove that these are similar. So our next job is to write the similarity of the triangles the way we want to see to check that they match up. I'm just going to start with ABC because most people would say it in that order, but be very careful. Don't just assume the next one's going to be triangle DEF because it's alphabetical order. Let's look carefully. We started out with A, and A was the 30-degree angle, so that means we must start out with E over here. And then you've just got to look and figure it out. Since I went A to B to C, and then back to A, I went through a side length of 6, a blank side, and then a 10.5. The 6 is definitely smaller than the 10.5, so let's look for that same order on the other triangle. That would not be go towards the 7 first. That would be go through the 4 first. So let's go E, F, D. That's how they match up, or that's how we're checking to see if they're similar. Are they definitely similar? So we've got one angle. We need to be able to get 2 sides around it. So that would be side AB, which is the 6. Lucky for us, there's numbers on those 2 sides. And here's the fun part about having it written out already. You can just look. You don't even have to look on the picture if that confuses you. 6 came from naming side AB. Just look right here. Say it's going to go with EF. And then you're going to check and make sure it's proportional with the other set of sides that we have any numbers on. And that would be AC from the left-hand triangle. And again, if you don't even want to look at the picture, AC should go with ED. Let's fill in what we've got, and I'll show you how to check for the scale factor. AB is 6, EF is 4, AC is 10.5. We're asking ourselves if it's going to be similar to 7. There's a couple ways you can do this. You can check cross products, or you can simply do the division. I do some of each all the time. But the question is, are these equivalent ratios, equivalent fractions? If you do it as division, you simply type in 6 divided by 4. That would give you 1.5. On this side, type in 10.5 divided by 7. That also gives you 1.5 exactly. Those are equal. So that's enough to say that they are in the same scale factor. The other way to do it would be those cross products. 6 times 7 is 42. 4 times 10.5 is also 42. As long as you can say yes, that's equal. You say yes, they're in the same scale factor. So because they're in the same scale factor, we're able to say this side and this side are proportional, and then the angle right here in between them says that by side, angle, side, the triangles are similar. Okay, my sound just screwed up while I'll take this whole slide, so I'm going to talk you back through it, even though I've written all over it. So the question was to determine whether the triangles were similar and explain your reasoning. Our reasoning would have been they're similar by angle, angle, side, or side, side, side. We marked out these two because there were no angles listed at all. Our next step was to try to set up the similarity statement so that we were checking it in the correct order. So when I wrote triangle ABC, I went ahead and tried to match up how to name the next triangle. You can't just say DEF because it's alphabetical order. So what we went by was we tried to determine a path like through the shortest, through the medium length, to the longest side length. So when we started with ABC, turned out we had these two 4.5s, so there wasn't really a short and a middle length. They were both the same length, but the long one was definitely 6. So that would be A to B, B to C, C to A. When you move over to triangle DEF, the shortest length was D to E. So we wrote DE first. The middle length was E to F. So we wrote DEEF. And then the last one was F to D. So triangle DEF would match naming it in the same order as ABC. Now, this one was pretty obvious because of those 4.5s, but what you typically check when the numbers are all different is you need to check all 3 side length ratios. That's what we were doing right here, so you need to write that down. Mine's already done. So I checked the short sides, 4.5 to 6. The medium length sides, which again on ABC is another 4.5, but the middle length on DEF was 7.5, so that was this middle ratio. And the longest lengths, 6 to 10. This is the time not to do necessarily cross products. You certainly can, but you would have to check them with all possible matches. To me, it's easier to do the division. 4.5 divided by 6, 4.5 divided by 7.5, and 6 divided by 10. When you do that division on your calculator, these are the decimal numbers you get, the decimal values of 0.75, 0.6, and 0.6. Turns out these two are equal, these two are not. So this right here is enough to say no, the triangles are not similar because we did not have it by side, side, side. Okay, other than me goofing up on that last slide, hope that didn't mess you up too much. What you're after here is anytime it says are triangles similar, please be thinking you have to somehow prove the AA, SAS, or SSS similarity statements. And then once you know they're similar, you can always set up proportions to find any missing lengths or angles for those similar triangles. Have a great day.